Hey everyone, welcome back. I'm Dr. Travis Goodson, the founder and chief learning officer at Biz Doc Consulting, and tonight we're on session 2 of 5, continuing on our conversation about bad data. So yesterday we wrapped up our conversation about leveraging data to drive a decision. If you haven't watched that episode yet, highly encourage you to go back in time and watch that one. Tonight we're going to be talking about the importance of understanding statistical analysis, at least a baseline, to help inform your decision to use different types of data. So what are the 4 main types of data, right? You have nominal, ordinal, interval, and ratio. How I teach my students is no oil in rivers, right? So there's 4 main types of data that you can use. These are all quantitative metrics. Qualitative data analysis is a whole other subject. But tonight I want to dedicate my time here talking about bad data, but we're going to talk about some of the interventions of how to turn that bad data into good data. So what makes it bad? Well, if you don't have an understanding of basic statistical analysis and the types of data that go into each type of test that you want to run, you're always going to be using the wrong data. So it's not necessarily that the data is flawed, but if you're trying to get a fish to climb a tree, I believe it was Albert Einstein, I see that quote floating around all the time on Instagram, you're always going to end up at the wrong spot. So what are the different types? We have nominal data. This is data that compares different categories, right? So there's no real structure. There's no rank. It's just, looking at, we'll say apples versus oranges. One's not better. One's not worse. They're just different things. So when you group data together, if you're comparing apples and oranges, that's nominal data. But what about ordinal data, right? So ordinal data is a little bit different. There is a rank to it. It's rank ordered data. So they're still 2 different things, but they have a hierarchy. So if I was to ask you, what's your favorite sports team and or who's your favorite life coach, you're probably going to say first is Travis Goodson and the second is whoever you pick. So there's going to be a rank to it. We're getting still in the subjectivity, objectivity realm, but at least here, if you're asking people, what's your preference for types of ice cream, they're going to list, strawberry, vanilla, mint chocolate chip, and so on and so forth. So you're going to have some type of, categorical data that's ranked. The next thing, no oil in, we get to interval data. So interval data is getting to that point where we're like, hey, there's starting to be some standardization. You're going to have equal points between variables. The way that I've always explained this to my students is if you look at heat, you're looking at Fahrenheit, you're looking at Celsius, or whatever mechanism you use to measure how warm it is or cool in your house, you have equal points between items on your scale. So obviously, 64 degrees is a lot cooler, Fahrenheit, than 76. And you know that because incrementally on that interval scale, that there are obvious differences. So what separates interval data from ratio data? Well, the difference is that interval data, maybe like an IQ score or, a temperature, when we get to ratio data, there's an absolute 0 point. So if you look at height specifically, not only is it, there's a rank to it, not only is there a structure to it, not only can it be objectively 6 feet is higher or taller than 3 feet, you have an absolute 0 point. So the absolute 0 point is when you say 0 inches, it's the absence of height. But if I was to say my house is 0 degrees Fahrenheit, it doesn't mean that there's the absence of any type of temperature. It just means that I have this scale to measure how hot and cold it is in my house. So when we get to that ratio data, it's like, the highest caliber of data we can have. We know that there's an absolute 0 point, which means that nothing exists. Okay. And then beyond that, if we go negative, we know that negative values exist. So what does this look like in a practical example? Well, if you're measuring money for data analysis, it's not interval, it's ratio, because $0 is the absence of any dollars. And negative dollar means, well, you're in the hole. You owe somebody something. Well, what if we're measuring, say, for instance, we want to know the ambient temperature in different types of warehouses. Well, we're going to go through and do the mathematics on it, collect data. This warehouse is 64 degrees, this one's 68, this one's 69. But say we're trying to equate that to a cost value for, say, an electric bill. Well, we're comparing 2 different types of data. Sometimes you can get away with that, but at the same time, it really helps to conceptualize. You're not going to measure interval ratio data against nominal data, right? You're going to try to marry those things up. So Yes, we can go through and say the production value of apples and oranges is different. It might be ordinal, but if we're examining it by cost, there's absolutely a correlation between 0 oranges sold and $0. Okay, so we're going to try to convert these things. We're going to make sense of the data. We're trying to drive a decision, but we need to have a basic understanding of the concepts of statistical analysis to make that happen. So the whole purpose tonight was to go through and provide a baseline for the rest of our conversations about bad data by informing us of the 4 main types of data, right? Nominal, ordinal, interval, and the supreme, which is ratio data. Thank you guys so much for tuning in tonight. I know it was really brief. I know we covered a lot. You guys can go through and use ChatGPT or, Bard or whatever you want to go through and get a more complex, comprehensive understanding of statistical analysis. But tonight, that's all I wanted to cover. I look forward to you coming to tomorrow with session 3 of our Bad Data series. Thank you so much for watching. I'll talk to you soon.